When Netflix made the switch from REST to GraphQL, they managed to cut their API calls by a whopping 90%. Meanwhile, Uber uses gRPC to handle millions of ride requests every single second with almost zero latency. And REST, well, it pretty much powers the entire web. So when you're building a real production system, which one should you actually pick? Let's dive in and break down the trade-offs.
All right, here's how we're going to tackle this. First, we'll get into REST, the standard that's native to HTTP. Then, we'll explore GraphQL, the super flexible query language. After that, we'll look at gRPC, the absolute king of performance. And to wrap it all up, we'll put everything together into a practical decision framework so you can confidently choose the right tool for your next big project.
So first up is REST. Now, it's super important to understand that REST isn't a protocol. It's really an architectural style that treats everything on the server as a resource. Just imagine your server is this huge digital filing cabinet. Every single piece of data is like a file sitting in a specific drawer, and each one has a totally unique address, or what we call a URI. And you interact with these files using a standard set of actions. To really get a handle on RESTful design, the Richardson Maturity Model is a great tool. So, level 0 is the most basic. You're just using HTTP to make some remote calls. Level 1 is where you introduce that core idea of resources, giving everything its own unique URI. Now, most of the APIs you probably used are at level 2. They use HTTP verbs like get and post the right way and give back meaningful status codes. But the real pinnacle, the holy grail, is level 3. This is where you use hypermedia, meaning the API response itself actually includes links that tell the client what it can do next. It makes the API truly self-discoverable.
But REST has this fundamental trade-off, right? It's all about its fixed data structures, and that leads to two really common problems. First, there's overfetching. That's when a single endpoint gives you back this massive object when really you only needed one or two fields from it. Then there's underfetching. This is where you get, say, the initial user data, but then you have to make a bunch more calls to get related info, like their recent orders. For a mobile client on a shaky network, all those extra round trips are an absolute latency killer.
And this right here brings us to GraphQL. It was literally designed to solve that exact over and underfetching problem. Now, it's not meant to replace REST for everything, but it's a query language for your API that completely flips the power dynamic. Instead of the server deciding what the response looks like, the client asks for exactly the data it needs, and it gets precisely that. Nothing more, nothing less. So, how does it all work? Well, a client sends just one post request to a single endpoint, usually /GraphQL, and that request contains a query that looks a lot like JSON. On the server side, that query gets validated against a schema. Then, for every single field the client asked for, a corresponding resolver function kicks in. And these resolvers are the real heart of GraphQL. They're the bits of code responsible for grabbing data from your databases, your other microservices, or any other API. The server then just pulls all those results together into one response that perfectly mirrors the shape of the original query.
But with all this incredible flexibility comes a classic trap, the N+1 query problem. Just imagine a query that asks for 10 users and for each of them their last 5 orders. A naive way to build this would run one query to get the 10 users and then 10 times more queries, one for each user's orders. That's 11 database hits for just one API call. It's a total performance disaster. The standard solution here is a pattern called data loader, which is smart enough to batch all those child queries into a single efficient database call.
Okay, so let's switch gears. What if raw performance and super low latency are your absolute top priorities, especially for your internal service-to-service communication? Well, then you need to know about gRPC. This isn't for your public-facing API. Think of this as the high-speed, private network just for your microservices. It was built by Google, and it leverages protocol buffers in HTTP/2 to get maximum efficiency. The gRPC workflow is what we call contract first. You actually start by defining all your services, methods, and message structures in a special .proto file. This file is your interface definition language, or IDL. Then you run the protocol buffer compiler, Prototalk, which automatically generates strongly typed client stubs and server skeletons in whatever language you're using. So in your actual application code, calling a remote service feels exactly like you're just calling a local function. It's seamless. Under the hood, your data gets serialized into a super compact binary format and sent over a persistent HTTP/2 connection.
So what we have here are 3 powerful but very different tools. We have REST for compatibility, GraphQL for flexibility, and gRPC for just raw speed. The key takeaway here isn't about which one is best overall, because that's the wrong question.
It's about which one is the right tool for a specific job. So let's build a little framework to help make that decision.
This table really lays it all out. You should probably choose REST for your public APIs, where compatibility and just making it easy for people to get started are key. I mean, every developer out there understands HTTP and JSON. You choose GraphQL when you're building for modern clients, like mobile apps or single-page web apps that need to pull in complex data efficiently. And you'll choose gRPC for your internal microservice mesh, where you control both ends of the wire and you just need the lowest possible latency. The data format kind of tells the whole story. Human-readable JSON for REST and GraphQL, and a machine-optimized binary format for gRPC.
But in reality, most sophisticated systems don't just pick one. They use a hybrid approach. A company like Slack is the perfect example of this. Their public API, the one for third-party developers, that's REST. But the data layer that powers their own mobile and desktop clients, that's GraphQL, acting as a kind of back-end for front-end. And all the communication between their internal services is a high-speed gRPC mesh. See? It's all about using the right tool for the job at each layer of your architecture.
So, as you design your next system, don't just think about the technology. Think about the contract that you're creating. Is the promise you're making compatibility and simplicity? Is it flexibility and client empowerment? Or is it raw, unadulterated performance? Because the choice you make right now will define the capabilities and the limitations of your system for years to come.